Hello! In this small video lecture we're gonna review a power rule. Even though we know power rule from lectures before, let's look at a few examples. Suppose we would like to find derivative of x cubed. We know that we can take and put 3 down, subtract 1 from 3 and get 3x squared is our answer. But what if we need to calculate the derivative of x to the 2/3? Then we don't really have a rule for that. So let's try to calculate this derivative of x to the 2/3. The rule would be the following. We will suppose that y is equal to x to the r, where r is a positive rational number. So if it's a positive rational number, then that means it can be written as p divided by q. Alright, so so if y is equal to x to the r, then derivative of y with respect to x is r times x to the r minus 1. So basically the previous rule would work, but it would work for the r, which is a rational number or fraction. So what would be the proof for this theorem? The proof for this theorem would be kind of straightforward. Let's try to do that. Let y equal to x to the r, or in our notation x to the p over q. So what we can do, we can take y equals to p over q and we can raise both sides to the power q. So we can raise the left side to the power q and the right side to the power q. So let's quickly review the rule for the exponents. If we have x raised to the n, which is raised to the m, the rule says this is x to the n times m. So our expression over here is x to the p over q raised to the so x to the p over q raised to the power q. So it's equal to x to the p over q times q. So we can see that we can divide q and we're gonna get x to the p. So our expression becomes y raised to the q equals x raised to the p. And then we can use implicit differentiation. So we will use implicit differentiation. Let's try to do that. So we'll take derivative on the left side and we're going to take derivative on the right side. What does it mean for us? For us that means power rule we can apply. So q goes down, then we have y to the q minus 1 times the derivative of y according to the chain rule. But on the right side, p goes down, then we have x to the p minus 1. So from here we can do the simplification. What we're going to do, we're going to divide both sides by q and y to the q minus 1. So we're going to divide by q, we're going to divide by y to the q minus 1. And here we're gonna do the same, q y to the q minus 1. Alright, so let's see what we're going to get. We're going to get that y derivative is equal to p divided by q and x to the p minus 1 divided by y to the q minus 1. So now what do we know about function y? We know that y is equal to the x to the p over q, and so we're going to plug it in for y over here. What do we get? We get y prime equals p divided by q times x to the p minus 1 divided by x to the p over q raised to the q minus 1. Alright, so let's try to simplify this expression. We have y prime equals p over q times x to the p minus 1 divided by x to the p over q times q minus 1. Alright, so now we have to simplify this expression. Let's look at the rules again. If we have x to the n divided by x to the m, that's x to the n minus m. So we're going to apply this rule to our expression. And this is equal to p divided by q times x to the p minus 1 minus p over q times q minus 1. Alright, which is equal to p over q times x p minus 1 minus, and we're going to distribute this expression through. So p over q times q minus and minus gives us plus p over q. If we distribute p over q through the expression, we can clearly see that we can divide this q and q, and we get p over q times x to the p minus 1 minus p plus p over q. This p and this p adds up to 0, and we get p over q times x to the p over q minus 1. But let's remember that p over q is actually our r, and this p over q is also r. So finally we have r times x to the r minus 1, which completes the proof. So we proved this expression. And how does it help us? Well, it helps us in a lot of different ways. Let's look at our example from before. So in this example, we have to find the derivative of square root of x. And even though we already know the answer, let's try to go a little bit differently this time. Let's think of square root of x as x to the 1/2. And we're going to take derivative. So we can apply power rule here. 1/2 goes down, and we have x to the 1/2 minus 1. So we get 1/2, and 1/2 minus 1 is negative 1/2. So we're going to get this expression, and we can stop here. But if you want to simplify, you have to take the negative exponent and move x to the denominator with positive exponent. And we also know that x to the 1/2 is the square root of x. And we got our old answer back. So that means we did everything right. Again, it's not really helpful in this example because we already knew the answer, but how about this example with a cube root of x? So if we want to find the derivative of cube root of x, we can either go by definition, but if you remember that's really hard, or we can rewrite cube root of x as x to the 1/3. Then according to the power rule, 1/3 goes down and we have 1/3 minus 1. Alright, so if we want to subtract 1/3 and 1, we have to take and put 3 into the denominator, put 3 into the numerator, and so we're going to get 1 minus 3 over 3, which is negative 2/3. So our answer over here is 1/3 times x to the negative 2/3. And that's probably good enough for all of our purposes. Since we're doing the power rule, let's do another example for the power rule. And this theorem is about the following. This theorem talks about this function. If y is equal to x to the negative r, where r is a non-negative rational number. Then derivative of y is derivative of x to the negative r is negative r x to the negative r minus 1. So pretty much the same rule as before works. Let's try to prove it. Our proof would be the following way. We have y equals x to the negative r, which can be written as 1 over x to the r. And if we would like to find derivative of this expression, we can use quotient rule. So it's going to be derivative of 1 times x to the r minus 1 times derivative of x to the r over x to the r squared. And we know that derivative of 1 is just 0. So that means the first part is just 0, and for the second part we can use the power rule. So r goes down and we have x to the r minus 1 divided by x to the r squared. So let's try to simplify this expression. We have negative r times x to the r minus 1, and on the bottom we have x to the r to the 2, which is x to the 2 times r. And then we're going to subtract the exponents. So x to the r minus 1 minus 2r. So then we're going to add these two numbers together. Negative 2r and r gives us negative r. So finally we get negative r times x to the negative r minus 1, which concludes this proof. Alright, so what would be an example for this theorem? An example would be something like this. Y equals x to the negative 5. So if you want to find the derivative of y, we have to find the derivative of x to the negative 5. And the rule says take negative 5, put it down, and multiply it by x to the negative 5 minus 1. So our final answer is negative 5x to the negative 6. Alright, so another example for this topic would be y equals x to the negative 2/3. So x to the negative 2/3, we would like to find derivative, so we're going to get derivative of y, and so we can apply the rule negative 2/3 goes down and we have x to the negative 2/3 minus 1. So final answer is we have to take negative 2/3 and subtract 1. So we're gonna write 3 and 3 in the both places. So it's negative 2 minus 3 over 3, which is negative 5 over 3. And that's our final answer for this exercise. Finally, there is one theorem which will go without proof about any real number. So what if we have R to be any real number? Then y equals to x to the r has the following derivative. So we have the same rule as before, but so the derivative of y is y prime equals to derivative of x to the r is equal to r x to the r minus 1, but for r we can use any number that we want. So no proof for this, but how do you use it in practice? In practice, if you need to find derivative of x to the square root of 2, which is irrational number, but we can still do it by taking square root of 2, putting it down, and taking x to the square root of 2 minus 1. Or if you want to find x to the pi derivative, you take pi, you put it down, and you write x to the pi minus 1. The only danger in this is if someone asks you what is the square root of 2 to the pi, what should be your answer? And of course the answer should be 0, because this is a constant. Alright, so this would be the end of this lecture. You will have to practice with these exercises in the homework, and I'll see you in the next lecture.